Uh, Good afternoon, everyone. My name is Akanksha, and I'm a student from IIIT Hyderabad, India. This summer, I interned with the Open Mainframe project, and I'm here to speak about my internship project.
Hello everyone, my name is SVK Rohit and I'm also a student from IIIT Hyderabad, India, and same as Akanksha, I interned with Open Mainframe project this summer, so we'll be presenting our intern project today.
I'd also like to introduce our mentor who mentored us for this project, Jichen. Say hi, Jichen. He works in IBM ZVM Development Labs. So, first of all, I'd like to talk about the Open Mainframe project. The Open Mainframe project is an open source community which intends to serve as a focal point for deployment of Linux on Linux OS in a mainframe computing environment. It also tries to increase collaboration across the mainframe community and aims to develop shared tool sets and resources for this community. If you want to know more about Open Mainframe project, you can follow these links. Let's talk about ZVM. ZVM is developed by IBM for running the virtual machine servers on the Z systems. It enables two-layer virtualization. That is, it has capabilities to support nested virtualization. That is, that a ZVM server can spawn multiple ZVM servers as well, and therefore like run a whole cluster. ZVM supports all IBM System Z engines, and it also supports all major operating systems like Linux, ZOS, ZVM, etc. It's powerful and versatile. It goes to extreme levels of resource sharing, and many limits of ZVM go well beyond other platforms. For example, it can spawn more VMs than any other platform available currently. There's a tight synergy between ZVM, Z hardware and Z stack, and this gives it new clustering and mobility capabilities. It also provides highly scalable services. So, with the increasing popularity of OpenStack, which is a widely used platform for building and managing private and public clouds, it was important for ZVM to leverage its popularity to be able to run in the cloud computing platform as well. So, to this end, the Cloud Stack on ZVM project started in 2014, and it has developed several ZVM drivers which interact with OpenStack components such as Nova and Neutron. ZVM uses XCAT, which is Extreme Cloud Administration Toolkit. It is designed to administer Linux OS on ZVM. Now, as you can see, the OpenStack compute currently uses XCAT to interact with ZHCP, which in turn enables it to interact with the ZVM. To provide more choices to our users, we decided to implement Libvirt and replace XCAT with it, so that Libvirt can interact with ZHCP, and which will interact with ZVM in return. More on that from my colleague Rohit. He'll be taking over.
Hi. The one reason that she showed is that she told was that ZVM users need to get cloud, and so we need to enable cloud on ZVM, that is on mainframes. So the result is that we need to have OpenStack enablement on ZVM mainframes. So how do we go about it? The things that right now choices we have is using XCAT and few drivers that are being developed by IBM in Nova and Neutron. So our project was to introduce ZVM driver inside Libvirt. Why? Because OpenStack Nova uses Libvirt for many of its hypervisor, for managing virtual machines, like for KVM, Zen, LXC, etc. So our project was to add ZVM into Libvirt. Now, how did we go about it? So in Libvirt, if you see the Libvirt architecture, Libvirt supports almost all hypervisors such as Zen, Kimu, OpenVZ, LXC, etc. So we needed to add ZVM driver into this list. so that Libvirt can manage virtual machines of ZVM. So each hypervisor in a Libvirt is called as a driver. So we needed to write a driver code inside Libvirt. Libvirt exposes public APIs for hypervisor functions. Suppose a public API might be getting a version of the hypervisor or creating a virtual machine of a hypervisor or adding volume to a hypervisor. So these are the public APIs exposed by Libvirt. So now each public API is associated with a driver API and a driver implementation. Suppose if I call the public API such as getting version of the hypervisor, then it will call the corresponding driver API and it will run the corresponding driver implementation of it. So we needed to add the code for ZVM driver inside Libvirt. Now Libvirt supports two kinds of hypervisor architecture. One is the client side and other is the server side. So if the hypervisor is present in the host where Libvirt is deployed, then it's called as client side, and if it's not, then it calls the remote and Libvirt takes care of it. Like it's accessed into the remote machine and takes connects to the hypervisor in that machine. Right now we have implemented only the client side version. Just a second. Piche. Okay. So there is something called as Virsh, which is a command line interface of Libvirt. Now each public API is connected to a command, which is nothing but a command line interface. So connect is a Virsh command which connects to the hypervisor, and version is a command to get the version of the hypervisor. Suppose if you see create test.xml, it creates a domain using the configuration in the XML. So these are Virsh commands. So we have implemented a proof of concept code for ZVM driver in Libvirt, which basically creates a VM using Libvirt. So we'll show you a demo right here.
No?
So SMCLI is a command line interface for ZVM, the hypervisor. So right now we are checking if there is a VM created with the name test. So it gives us an error. So there is no VM with name test. So we run the Virsh command line interface of Libvirt. And connect to the ZVM hypervisor. So it successfully created a domain. A domain is like a VM in Libvirt's terminology. So let's check again using the command line interface of ZVM. So it shows some output. The output is nothing but the configuration of the VM created. So this is just a POC that we have created, like just one public API of Libvirt. So there are many other public APIs of Libvirt which needs to be implemented, and that will be a future scope, like a complete ZVM driver package inside Libvirt, so that OpenStack can directly spawn ZVM virtual machines in mainframes. So this is like a OpenStack enablement on mainframes. So that's it. Thank you. We would like to thank the project Open Mainframe and our mentor Jichen for guiding us and giving this opportunity to present here.